Our next presenter is Anh-Vu Do. The presentation is titled 3D Printing for Tissue Engineering.
War. What is it good for? Some may say absolutely nothing. However, soldiers in the line of fire often incur injuries that require organ and tissue transplantation. Similar to these soldiers, patients suffering from organ failure or some freak accidents are also in need of transplant. So the solution seems quite simple, right? Why not provide all those with the transplants that they need? The issue lies in the shortage of organs and tissues, where the number of people on the waiting list for a transplant grows exponentially each year, and that this number is 10 times larger than the amount of donors available. Let me put this into perspective for you. 20 people die each day waiting for a transplant. And to add insult to injury, there's an additional issue of rejection, where when you take another person's tissue or organs and place it inside of the patient's body sometimes recognizes this as a foreign entity and directs the immune response to attack it, making the transplant non-functional. My research focuses on using 3D printing to regrow tissue with the ultimate goal of regrowing organs. It is important for us to focus on regrowing tissue first because organs comprise of functional tissue. As seen here, with 3D printing techniques such as stereolithography and fused deposition modeling can create scaffolds and structures similar to what you see in B. And these structures can be in any size and shape to confer to any injury sites with the ability to regrow tissue. And to fabricate these structures, 3D printing uses a process known as additive manufacturing. Additive manufacturing is basically just a fancy way of saying that we build structures in a layer-by-layer process, similar to building a Lego structure. And as with all Lego creations, each component is vital to the overall structure. When 3D printing is combined with biodegradable materials, novel drugs, and the ability to control when these drugs are released, we're able to mimic the tissue regeneration process of the body. And what's even more fascinating is that when we incorporate stem cell research into this technology, we're able to completely eliminate the issues of rejection, where now we're able to regrow tissues using the patient's own cells. As seen in C, when we combine all these components together, we are able to regrow tissue. What you see here specifically is we were able to regrow bone tissue. And what's interesting about this is that we're able to regrow tissue at a rate that is better than the natural healing process of the body. With 3D printing, we have seen the successes of its ability to regrow tissue, and we hope that this translates to its ability to regrow organs. It is our hope that 3D printing will meet the demands for organs and tissues, and that one day we can print a better quality of life for patients. Thank you.